Am I live? Is this working? Is this working? Or am I in the wrong stream? Am I live? Is this working? Is this working? I guess it is. Alright, it looks like I am indeed live. Alright, so what are we going to do today? Well, first of all, this is more or less still testing. You know, I'd appreciate people letting me know how everything is, audio, video, I don't know what. It is streaming 1080p supposedly, so hopefully it's looking alright. If text is too small, let me know. I'm on a 4K monitor, so sometimes I don't get that quite right. So today I'm going to work a little bit on my Sudoku tools repo, where I'm hoping to collect some shared open sourced tooling and information for Sudoku stuff. Hopefully in the future being able to create things like a shared data format, import, export for the different tools and so on and so forth, and just collaborate on some ideas. I'm going to start with cleaning some stuff up here because let me just see if I can make this bigger. Because I recently did some work of trying to get my video analysis tooling to work servers purely in Node. The only issue is that it takes a lot of extra install stuff. So let's have a quick look at that. So the idea would be to log SCF. Oh no, this was compression work. Oh yeah, I was working on, oh yeah, now I remember, sorry. Oh my god, that was a while ago. I was testing some compression stuff and I'm not happy with the outcome. So the idea was, can I bulk compress, like if I have 1 million puzzles or 10 million puzzles in a file, can I use the fact that these puzzles are mostly similar and sorted as a way of just encoding differences between the puzzles? And while, yes, I can, the end result doesn't compress as well. And after the zip compression, I still ended up worse. So I don't even know if I want to push this. I probably want to push the generic tools files, but the compression itself, you know what? I'm going to keep it simple for now. I'm just going to push it in bulk. So pus debug. Yeah, there's just some libraries, some generic bulk compression attempt failed. All right, I'm just gonna push these in. So what I really want to do today is a little separate thing, because we've long since been talking about, or I've been thinking about how to create a shared format, because currently we have this weird situation where the CTC web app has an internal format that is hardly used and doesn't really do much. Then it had an import from the CTC format, and during that import process, it basically renders most of the stuff. And now it has an import from fpuzzles where it converts it to the CTC format. So it's a bit of a mess, and there isn't really a good internal format. And now there's Sudoku Studio coming along, and Sudoku Studio, I hope, is going to do things better. But in the long run, I think we need a solid import-export between the different formats. We need to be able to go both ways. Like, we need to be able to go into CTC format and back out to fpuzzles and vice versa. And for various reasons, that's actually really hard at the moment, because things like fpuzzles, for example, the cosmetics don't support fractional coordinates. So you can't just draw a line somewhere inside a cell and things like that, right? So what I want to do is I want to think a little bit about just very low-level structures, very simple things. And this falls under format conversion, maybe this one. Kind of how to define things. So for example, under basic cosmetics, I want to be able to place SVG data, you know? Now, at a previous game studio I worked at, we had a custom compressed SVG format, which was super tiny. And while I can't reuse that code, obviously, I can reuse the principle. So we could have something like highly compressed SVG data for basic primitives, line drawing, circles, squares, arrows, things like that. While, yes, it would still be custom data, the fact that it's really just a compressed format of SVG, and we can still support SVG, means that we could, for cosmetics, we could basically have three supports. So basic cosmetics could go three ways. It could be custom primitives, you know, lines, circles, right? Then basic SVG support, some subset of SVG, comma, encoded generically. Like base64, URL, encoded whatever, and then compressed SVG data. So there's some generic compression format that just compresses SVG, because the idea here is that you don't have custom rendering. For this, you have to do custom rendering, right? Now, if your end target, you know, FPuzzles is canvas based, right? If your end goal is not SVG, then you obviously have to render the SVG to data, but you can use like things like CanVG, and there's all sorts of tools for doing that, right? So you can always convert SVG data to a bitmap. All right, so let's have a look at, I mean, the code organization is going to be pretty atrocious at the moment. I kind of have the source folder. So we have source here. Yeah, that's changed already. Compression, yeah. So we have these generic files, and ultimately these need to go into places. But right now, I think what I'm going to do is I'm just going to create a folder, and then just start kind of keeping things separately for now until they become bigger. So data, formats, format, right? And let's just create a file, and let's call this data primitives, right? Something like that. So we put that in here, primitives, right? And I personally, yeah, so we don't have an npm registry here yet, so we probably want to create that too. I think that makes sense. So we're just gonna go a little generic here. Let's do that. Yeah. Something like that. And let's leave that out. Well, I'll put my name in here for now, but in the future it's going to be different. All right. Now, it asks for a entry file, and I think the entry file should eventually be like a demo, like a, you know, hey, this is what you can do, kind of like a menu, kind of like a self-documented interactive documentation type thing. But we're just going to leave it empty. We're just going to do this. And let's get all this clutter out of the way. Yeah, so personally, I have not yet worked with the module type. So I actually want to look that up. Node module, yes, 6 module. So we can use import and all this stuff. And it'll be my introduction to this kind of modern world. I don't know if it's a good idea, because obviously we want to be browser compatible, so a lot of the stuff will be super primitive. And I don't know exactly how that affects things. So Module packages, input type, JS type, input type, module package for more details. So, oh, and now my nose is itching. 1 second. It always does that when I start streaming. And then it settles down eventually, I don't know why. So, just and the nearest parent package contains the top level type field value of module. Okay, so let's put a type in here. And then we're gonna have to deal with how that actually works in the end. And then this is how you import it. And we're exporting things. Okay, this is all package JSON stuff. Also works scope package, for example. This could will also work. Okay, so what I'm gonna try to do is keep it browser compatible, just with kind of something like this. Browser compatible module 6. Let's see if there's something like standard sort of best practices syntax. I mean, man, it's been a while since I've dealt with this stuff. HTML.js export function tag. So export is a thing in a browser. Oops. Export. Export function. Expected token export. So that obviously doesn't look good. Whoops, sorry about that. All right, well, let's just stick with what we know works. So we're going to do something like this. And probably we're going to do something like this. And then what I like to do, oops. And we probably need some sort of top level namespace. Something like this. And then usually we'll just do something like that. And then internally, usually I use some sort of something like a short form. So we don't have to have, you know, data primitives all over the code. All right. And the first design I want to think about is fractional RC values, which I don't actually know. Well, we'll be referencing the web app code a lot. So let's have a look. Let's pop it open. Let's put it down here for a sec. And the goal is obviously also to kind of simplify this, because this is, you know, 4,000 lines of code, and it's really all in one big lump. I think I have an RC library somewhere like maybe in utilities or something. But the idea is to kind of organize this code on the outside first and then bring it back together and you use it in the app as well, right? So let's have a look where the RC tooling is here. Because there's two kinds of RC tooling, right? There's the maths on the RC stuff. And then there is kind of the data format stuff, right? And that actually, to me, it looks like it might make sense to actually create an RC class with, you know, kind of similar to the math class. And pull stuff like that in there. Now, I don't see it here. So it's actually going to be interesting to find out where that is. So we have 2RC, RC val. Because, for example, one format I'm using here is a hex format. And that's a little dangerous because obviously it's not compatible. So the question is, okay, so this is, for example, one of the questions I want to tackle here. In the past, to support larger puzzles while also maintaining a compact format, and let's just do something like RC, and then we'll just have a little bit of something here, and we kind of leave this for later. So we can have something like, or maybe we'll do this in here. Yeah, I guess. Plans. Considerations, is that the right word? Let's do something like this. And see. So, what could our C kinds look like? So we could have something like R1, C1 through R9, C9. Or 0 through 0 base is what I personally would prefer, and I think that is what I'm using internally. In fact, while we're here, we might as well poke around at the data a little bit. So, for example, framework holds all the top level stuff. Let's have a look at the puzzle. So if I look at the replay stack, for example, so let's clear this out, refresh it. So the stack is empty. Select the first one, put a 1 in there. Now the replay stack has this. So it's actually 1 based instead of 0 based. I guess that's fine. And that's the other thing. Everything needs a internal storage format and a interaction format, right? Something to type in for. So for user interaction, R1C1 might make sense, multi-digit, no problem. And then how we encode it internally, including a binary encoding, you know. So for example, by having a simple 2-digit hex presentation and dropping the R and C altogether, suddenly your 4 characters become 2 characters, and you don't even need to worry about bitwise number encoding and all that sort of thing. But, plain 9x9. Then we can have hex. So we could have R1, C1 through something like R, FF, CFF. And then what I did here is I basically used lowercase and uppercase to differentiate them, which can cause problems because there are places where things get lowercased or compression causes issues. So again, considerations, right? Then there can be, and there is something to be said to say, hey, is 16 by 16 big enough? Or do you do a base 20 or base 24, base 32, right? That's all possible, especially if you have the single digit encoding. So you could have something like R1C1, especially if you have this sort of structure, then you can have RZCZ, right? And this could mean to, 26 plus 10. 26 characters plus 10 digits, or 9 digits in this case, so let's call it 35, right? And you can go as high as you want, right? And in this case, you could do this for a 16 by 16, right? This is extraneous. Then fractional. So when the data comes in from a CTC puzzle, and let's have a quick look here if we have one. I think something like this, for example. So if we look at the data of something like this, actually let's just open the puzzle, the raw data directly. Might as well. It's BLL. Gonna be a pain in the butt. BLL. We're in the D's. B. I have a hard time seeing this with the video light right there. BP, BJ. Gotta be after J, right? J, BL. And then do we have a G? Yeah, so it's this one. Right, so this would be the raw data. And so this is the compactified data, right? Puzzle tools dot. Now we have a bunch of tooling already, which I need to clean up and move into better organized stuff, but I want to do it cautiously, right? So we have puzzle loader, puzzle tools, and puzzle zipper. Now the puzzle zipper turns this mess into regular JSON. So if I unzip something like this, right, I should get out real JSON data. Right, and then I can actually do something like something like that. And we probably want to console log it. Can I do this? Yeah. And now we're up to 11 kilobytes. And we started at, how big was this? 4,800, so it's already 2/3 the size. But it's, why does it not output? Console log, JSON stringify. This should write to the console with line breaks. JSON. Oh, because that's okay. So that's a JSON string. So we first need to parse it, then we can restringify it to pretty print it, right? Now I can copy that, put it here. No. Right. This is cumbersome. I'm gonna do this. Oop. I'm going to say let pos equals. I'm gonna store this in a variable, right? Then we're going to. So let pos equals, just as a reference, so I know what's going on. And so you guys can see, because that console is a bit small, I think. In fact, I'll make it bigger. All right. And then we'll do puzzle tools.unzip buzz. And that should give us the unzipped version. Nope, puzzle zipper. I have to be careful because I have different tools with the same names, and that's also something I need to refactor. Yep. And then we'll want to parse this, I think, because this is not JSON data, that's a stringified JSON, right? So parse it. That should give us actual JSON data now. And I'm scrolling the scroll wheel while I was pressing the control button. Here we go. And now, stringify. Now we can pretty print this. I thought this is what I did before. It gives us this encoding. So if I log this out, shouldn't that be all decoded? Yeah, that looks decoded to me. Yeah, all right, here we go. Now let's change this to tabs and to... Does this have a JSON? Oh, JavaScript should be enough. All right. And then we can collapse it. And this is our data, right? Now, what I want to look is as the lines. Yeah. So you see, this is how the lines are represented. So this is not an RC format, but it's also not a particularly non-compact format, right? And if we just get this part, so the raw, nope, it's parsed. The raw JSON data, the unzipped JSON data, right? And we put that somewhere. So we can look at the waypoints down here somewhere. Yeah. So this is actually a fairly compact format as well. Now, one disadvantage this format has is that we need to distinguish, but it's JSON, so we can just do plain JSON, right? So we can do options JSON, right? So we can have something like this. And, you know, to make it clear, a singular cell, we can do something like this. This can go up to 99. Right? So this is also very compact. It's 1, 2, 3, 4, 5 characters. Now well, technically we could put these back to back without a separating character. Like we could get rid of the commas, right? We could make a definition that works like this. Syntactically, no problem to parse that. And we can do something like this. You know, we can do R1, C1, R2, C3, R7, C2, you know, and we can easily parse this out. So let's try fractional RC values. Now that adds additional length, right? So currently here, this gives us 1, 2, 3 characters. I mean, the spaces are, we can skip those, right? So, and we'll do a side-by-side comparison for that as well. So then we can do fractional RC. So that would be something like R 2.5, C 3.2. The nice thing about this is it should be fairly simple to adapt existing parsers to it. It's just a parsing problem. And then internally they can be handled just the same. You know, if you need a round number, you round it or you floor it. In this case, you probably want to floor them most of the time. And the flooring would give you the cell, you know, so 2.9 should still be within row 2, not row 3. And this is now, well, 1, 2, 3, 4, 5, 6, 7, 8. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Because we have a beginning and end character, which we don't need here. Because we know we can parse. The only time we would need it is if a number could follow right after. because if we get another R here, we know we're continuing, right? It gives us a limit on the resolution. This is 1/10 of a cell, right? We could do fractional RC hex. So we could have our 2.f. So we would have 16 subdivisions, right? We could do that as well. Doesn't add any additional things. We could... Now, what I like about fractional is that a non-fractional display is compatible. It's forward compatible, right? So we don't have to handle these extra. A more compact format for internal storage might be to just have higher subdivisions, right? So in other words, fixed point. So you could say, hey, each cell is actually 10 units across. So all the numbers are multiplied. And that way you can just get rid of the dot, right? You just shift the dot off and you don't store it. So for example, you could use a 2-digit hex, right? And then represent that as 16 cells. So we can do fixed point x RC. So that could be R FF CFF equals, that would be equaling to R 16 point, and now we actually have 1/16, right? R 15/16, nope, right? So it would be this. And if we do something like 2A, so A would be, we have 9, so that would be 10/16, right? So that would be, that's what we see, and then it will be 2.625, for example, right? And actually, to demonstrate, we should be able to do half, right? Yeah. So if this is an 8, you know, we can do 2.5, which is kind of important. And we can do 2.25 as a 4, right? And we can do 125. We're just doing in eighths, right? Call it imperial measures. For sure. So that's another way. It's harder to read for humans. The nice thing is if you can guarantee that your board is less than 60 by 16, or at least that you know every data within this particular definition is that, then you can get rid of the RC as well. And then you're just storing 4 characters, right? And you could easily say, hey, if the board is larger, you know, we have 3 characters, 3 hex characters, so it's 6 characters per cell reference and so on. And you're only 1 character over this, but now you're dealing with boards up to 256 by 256 and 16 decimals of resolution, right? Of course, this might make most sense for human readable stuff, and obviously by allowing multiple decimal places, you know, it's still super generic. But then in the end, you could literally just do this as well. I don't know. For human readable, this might be easier too. Don't know. And to be honest, 1/10 of a cell might be enough. It might be enough to even position something like the edges. Although internally, these edges are actually, the cage offsets are actually a little dodgy because they are less than 1/10 quite often. So if I look at rendering cage, right? Yeah, the offsets are all over the place, right? Because this is internally, it's all cell relative, right? And what I would like to do for this tooling exercise is actually to just implement all of them and like implement parsers, kind of create rock solid code that can handle any of these. And then you just come up with names for all of them, and then you have a big library, and then at the end, you know, maybe you run some test codes, and then you can, amongst the community, decide what you're actually going to use. And every time you have a list of RC values, you know, you might even have a little format marker. Hey, this is JSON, or this is whatever. Or ideally, what I did with the Puzzle Tools library, here I ended up with a getPuzzleFormat function, and then various checkers to see, hey, is this data, a pzipped data, right? And it just kind of tries it and see if it unzips and doesn't blow up, Is this an fzip data, right? Does it run through if I decompress this and parse it as fpuzzle data, do I get real data out of it? Yes. Okay, it's fpuzzles data. If not, nope, it's not as fpuzzles data, right? And then some data is harder to check and so on and so forth. Ideally, we have some sort of generic, kind of like video formats. You have a generic container format, and you kind of just say, hey, you put a format marker here, you put a version number here, that kind of thing, right? All right. So what else can we do? I mean, yeah, so then obviously I have the tooling as well. So for RC, for example, it makes sense to have simple stuff like, hey, give me the roundings, check if two RC values are the same, give me the center of a cell. This one is what I use a lot for. Basically, we're just saying, hey, if, and this is actually using a optimized Bresenham implementation, which is probably unnecessary. Actually, no, does it? Yeah, it does. So it's saying, hey, between two RC values, give me all the cells in between. So as I'm moving a mouse quickly on selection, it doesn't skip if the mouse is moving too fast, that kind of thing. And it's good for other things as well, right? So now I'm thinking, do I want to implement this all as one humongous RC object with all sorts of methods on it? Or do I want to separate the whole format conversion from, basically have like an internal RC vector function class that just manages data, right? And not really storage. And then you have like export to, write to string, write to JSON, all that sort of thing. Because internally, obviously, makes sense to just store them as fractional values, right? So let's start with that. Let's create an RC class, right? So we're going to just say, and I'm going to keep it simple, right? And then at the end, we'll say dp.rc equals rc. And then later on, maybe we want to do a, or we can probably do something like this actually for now. Don't think we need all this stuff here. Right? Don't know if we want to have the RC as a separate object that we can reference. Basically, if I use this syntax and put things in here, I don't think I can reference RC from in here. While if I create the object first and then assign a bunch of extra stuff to it, like this, then I can reference RC from within these methods and functions, right? Now, RC should also manage RC lists quite handily, right? So here, these are all, excuse me, I have an itch, there's a microphone in the way. These are all numerically based, and internally that's exactly what we should do, right? And 2RC in this case just means take a, yeah, that's another thing. Do we want to handle it as internally as 2 element arrays for efficiency, or do we want to have it for, .r.c as sort of neat objects to handle more cleanly? Lately, I've been trying to stick with arrays, just in case you do a lot of stuff. It's very easy to kind of, become inefficient. You can work with arrays fairly easily, and it's quite efficient internally in code as well. But it's not the clearest, right? It would make more sense to have these split out. But let's just port some of this stuff in, right? And I mean, some of this stuff I can literally just bring over. So we can say to RC, and that takes an array of 2 elements and just gives back the floors of each of these 2 elements, right? Then here we can just say equals, and I guess it just compares the elements actually. And here, this is sort of, where we want to overload them a little bit because we have 2 elements. And we're doing a full-on comparison. And then we want to have RC equals, basically. Do we want just the row and the column equal, right? And then in this case, we have the option of manually doing this internally or doing these first. But I think, you know, we want to keep these implementations efficient as well, so people can use them without having to kind of worry about it, right? So we basically just want to floor all of this. And we'll just kind of standardize on having, oop, that's another one, elements, you know, RC1, RC2, elements 1, 2. I mean, for sorting, I usually use A and B to not imply any kind of particular ordering, but I think this is fine. Now, the other question I have is, should I implement these functions separately in here so I can actually use them rather than having to call rc.toRC? So basically the other option is to have these actually pulled out like this, kind of like what I'm doing with the data primitives, right? Do this for all of them as separate functions. And then pull them back together into the object to export them as a library. But internally here, I can just use them directly, right? And then I can just say RC equals all of these kind of like that. Yeah, and then I don't have to worry about that either. I think that's what I'll do. Right. And then round center. RC center. I think we can drop the round. I'll just do this implementation here. Can make this a bit wider. This is going to be mostly about the code. So the stream is not going to look pretty, I'm afraid. Oop. And we're just going to truck on creating a lot of this sort of stuff. Very primitive, nothing complex, you know. But mostly just to agree on certain things, right? Step points. And of course, I mean, this is going to be a little bit, hey, I'm doing the things I need. Now this is actually generic, because it's taking a handler. Does this, yeah, so I'm gonna need a way of testing this very easily. So I'm gonna go down here. I'm just gonna do node, and we can do that actually. We have a test, nope, not this one. We have our little test index file. And we're gonna look up exactly how we're supposed to do this correctly. So we should be able to just do import from here. From primitives, import asterisk as primitives from primitives, right? Would that work? What? So node src/index. Okay, cannot find my module source primitives because it's under format. Format primitives. No. Primitives, because I misspelled it. All right. Module is not defined in because it has a .js contains type module. To trust it as a common JS script. The file is being treated as an ES because it has a reference is not defined as an ES module scope. If module is not defined in ES module scope, okay. So I'm guessing there's something I need to do differently. I don't like the MJS extension. I don't know why. I'm guessing because of browser compatibility. And it's like, I come across these and then, oh, hey, Bremster. Ah, excellent. Excellent. Love to see it. Is it gone live already? Wait 1 second. I gotta see this. Want to see it? Where is it? Am I not subscribed to you with this channel? I am subscribed to you with this channel. Is it the one that went live 23 hours ago? Ah, all right. No worries. I'd appreciate like a screenshot just to see if everything worked out with the lines and the styling and all that. So export, you're missing is import with common.js at the bottom. You have CSJS. The S module equivalent is export default. If type of export is undefined, then export data primitive, something like that. Unexpected token export. Unexpected token export. So how do I do export? It is supposed to be a module. All right, you know what? I'm not gonna waste my time on that stuff. That's why I always don't end up doing this. I need to one day sit down and figure out exactly what's going on. I don't know why they don't make it more compatible. I've done like portable stuff that just works with all of the different things before, and this is, I don't know. I still find these differentiations to be a bit garbage. Query is not defined in ES module scope. Oh my god, are you kidding me? Well, I'm trying to use import, but you're not letting me. You're not letting me. All right, let's try that then. Why can't I rename from up there? That's also a bit bollocks. All right, so I should be able to do this now. I hate like when it says solved. It usually means it's not solved. It's like, it's such a stupid thing. It is set to module. The file is called an MJS file. I've done all these things. It is set type module. So bugger off. Yeah, I've done all these things. Don't tell me to do things that I've already done. Yeah, so this is just not working. Node type module ignored. Well, I'm pretty sure I am in version 16. Oh, really? Well, yeah, that's not it. That's not a problem. Take care, have a good night. Ah, what pretty arrows. What pretty arrows. Change it to what I suggested and everything works. Time just for my index file was a generator for the version. Being able to use models. I then updated my node return, did change, and just rename index. What? Import R from RAM there. Nope, it doesn't work. Module package 17. Alright, so that's the modules documentation. My neck hurts leaning over like that. Okay, except it's not. So import. I should be able to just do this, right? Don't know if I need semicolons here or not. Nope. Problem is the export. Set the main entry point for a package is defined in main true conditional exports. But it's not, I'm not talking about the package, I'm talking about the file itself. Subpath, export subpath, input type, determine package manner, nested condition, solving user dual comment. Okay, how about this? Since Node.js ignores and still separate PKG, yes, mode, both the same separate condition. Node.js fine before evaluation. Dual package hazard. Remember, the new package that provides both the risk of certain bugs if both versions of package get loaded. It comes from the fact that package is created by incident. Right, node how to use export. Holy crap, like, why is this so hard? It should not be this hard. It really should not be this hard. Ah, man. Well, I have an MJS file and it won't let me export. Universal module definition can be both in the browser and but the module needs to be imported a number of different module loaders. Okay, but this does work for MJS. So what if I do this? Module is not defined in ES module scope, but export is also not defined. Note, neither module nor export work. So, what the heck? Should fail to even import as you are attempting to do a named export of the CJS module. What? Should not be loaded as eSIM but as CJS. I still, like, there isn't a single piece of documentation of just how to do it. How to export MJS. It's only talk about importing, but to be able to import, you have to export as well. Like, what the heck? This does not work. I can copy it directly from the example and it will not work. I'm wrong. Why the hell does this work? I am very wrong here. What the heck? And why does this not work then? Unexpected token export. No. Do I have to export everything individually? What is going on here? And I don't want Babel things. I don't want old things. I need a modern version 16 explanation here, because I'm obviously not running on an old system. But it doesn't. It doesn't. This is not correct. This is wrong. This is all wrong. Note 16. Oh, come on, Google. Ah, Google. It just ignores search queries these days. CJM syntax. Can I have like a 2021 result to this? Seriously, Google. Seriously, Google. I don't know where CJM came from. No, no, don't change it. And surviving, all right. That's what I need to do. I need to survive. So I have to export everything individually? I mean, yes, it's unexpected, I guess, but... God. Seriously, that's all I needed? Can I... What is the export syntax? Node export syntax. Can I get, like, just... description of the export command. The export statement is used when creating JavaScript node to export live bindings to functions, objects, primitive values from the module so they can... Okay, isn't that constant a primitive value? So it needs one of these. So... This is so annoying. What does export default mean? All right, well, right now I just care as primitives. And I probably wanna something like this. All right. So now I should be able to do something like this and do something like this. Nope. Does not provide an export named. All right, I still don't fully understand it. It's not set default. If I say import things, data primitives, is that the distinguishing element? Import as export does not set the default export as export from. Export Destructure assignment with renaming. Renaming exports. Export list. Export as name from. Export import as name. Oh my god, what the hell? So how do I replicate? Oh my god, okay. Module convert CJS to MJS. Maybe that'll help me. What the new syntax is for this to do? They're just the same thing. Just the same thing. So I do have to write them out separately. That's going to be a huge pain in the butt. So I cannot export something that I've declared earlier. Can I do something like export RC from that? Can I do something like that? Import asterisk from. Import asterisk from. So that doesn't work anymore now. Import from. I thought the import from syntax would work. Import from. Input asterisk as RC from exports and experiment. Okay. So how's that supposed to work? The official standard format code for use. Safe to say that ESMod is the future. They're now the official standard format. Okay. No matter if in the browser or Node.js. Both systems allow you to import. Yeah. The question is, why is the syntax so incompatible? Holy crap. Alright. Like, I can read it. I can't write it, though. Okay. That's not a good sign. So, exports. Asterisk as module name, named exports. Can we see some examples here? Export named exports, variable statement. So I can do a variable statement. The syntax so exported by an external export variable statement. Where is variable statement? Variable statement. Var. Oh, that's what they mean. Like var, let, etc. Can I get back to where I was a second ago? Declaration. Default hoist class look ahead function. So if I do export default, data parameter is not defined. Yeah, okay, that's fine. Okay. RC. Does not provide an export named RC. But it does provide, oh my god. So MJS access properties. You know what? I'm gonna stop fighting it. I'm just gonna do export wait. MJS destructuring export. No, but my god, how can I not import parts of the export? This is driving me crazy. All right, let's do this. So if I do this and then do export const RC, what if I do this? Okay, so now I can get a named RC out of there. Maybe that's all I need to do. Maybe I need to stop fighting it. Stop trying to do things my way. Okay, And then we can do things like rc dot, and it's rc equals, and we have step points. Step rc. Let's prefix things that operate on a specific rc value, right? That rounds it down basically, or floors it, right? The step rc step, and this would be 1 1. And in the future we can maybe overload these as well, and we can do 2 7, right? And that should, yeah, rc step is not a function. We haven't added it in here yet, right? Handler. I guess the most primitive thing would be just to do this. I probably want to do a const no op. What? So we probably want to look at why this is going endlessly, right? Net limit both 999 while true, while limit minus greater than 0. So this doesn't reduce at all. Wait. What? Sorry, I'm feeling a bit dumb right now. So, oh Jesus, they're separate. Okay, so this is also something I probably need to. Yeah, so this is actually not part of RC here. This is just a generic step function. So if I'm gonna make that part of RC, I need to actually accept RC values, right? So it needs to look like this, right? And then we probably want to rename these to, so X would be columns, right? And then Y's would be R's. R, D. Wait, X is columns, DC. Okay, so all the X's become C's. All the X's become C's. Let's do this first. So I don't make a mistake. I'll still make a mistake. No more X's. And now all the Y's become R's. R, 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 and this is searching my brain. This feels wrong. There feels something wrong. It feels wrong. Where's utilities? Let's compare. Yeah, I haven't done Bresenham often enough recently that, yeah, okay. That's actually, it is what it is. All right. So C, so we have S. So if DC, DR, we have C0, So these would be row 0 call 0, and then row 1 call 1. And then here we have the 1s and 2s. So I'm either going to change these or I'm going to change these. And I'm tempted to go for 0 based. So then these become 0s and these become 1s. So 0, 1, 0, 1, 0, 1, 0, 1. That's one sort of advantage of doing it like this. You kind of can realize all these inconsistencies and clean them up. X 0, 0. Okay, so X becomes column, and that becomes row. X1 is not defined, so I'm still. Yeah, here we go. X is column. Okay, 1 1 7 2. That's the in. Blah blah blah. 1 1 2 1 3 1 4 1 5 2 6 2 7 2. Nope. All right. So go to the no up, and in our test script here, we're just gonna do. And the handler will get this as an array like that. Now, talking about optimizations, this is creating an array here when we already have an array. Now the problem is if I keep it as an array, I need to make a copy anyways, right? So these I'm not changing. So the question is, do I destructure it here and then use an array when I'm iterating? I have array references, but I'm not creating a garbage array every time. Yeah, I think that makes more sense, right? So we're doing all of this, and we say let RC equals R0 C0. And then we can use RC in here, right? If RZ, wait, is this row or column? This is column. So this is RC1 and RC0. And then we probably want to swap them now, because in this world, the rows come before the columns, while in the XY world, the X's come before the Y's. That's just how it is. I don't make the rules. Then here, this would be row, this would be RC0 for the row, and then RC1 for the column. So we want to swap these as well, just to stay consistent, right? And 1 1 1 2 1 3 1 4 2 5 2 6 2 7. Yeah. So that's our standard Bresenham. We're just looping through it, and that's it. And that should give us a more or less continuous kind of line. And we can step across. There we go. And we probably want a second function that just gives us those values back, which doesn't have a function call. So if we do need to do something like a lot as part of some sort of search algorithm, we don't want to have that stuff in here. So we want to have an RC what we kind of call this. RC line. It's basically the same algorithm. I need to come up with a better name here. Now we know how long it's going to be, right? We can do this again. Not true. Do that. Because we know how we're stepping. We know that the smaller one is going to do the thing, right? So let me just output these quickly, get my head around it. Like I said, it's been a while. We should know these are positive direction. And array error. We have an initial error value, right? Error value is 5. And I'm getting cold. I'm gonna take a break soon. I mean, we know the deltas, right? So we have just do this. We have the S and the D for the delta, and what was the S for? Ah, the step size, all right. So we could really just do math.max on this. Math.max. Range, right? And that should tell us the maximum number of elements we're going to get. 1, 2, 3, 4, 5, 6, 7. The delta is 6, but we're including both ends. So is it always going to be 1 greater? Because we're including both endpoints, and the delta is the number of steps we're making, which is 1 less than the number of points. Okay. So we know, you know how many points we're going to get. So we can say let points equals boom. And then point count, right? And then let I just do RC count and RC list equals array RC count, while RC count plus 1, right? And then while RC count minus minus is greater than 0, console.log RC. Right, so we have RC line, RC step, and then here we can do RC line. Okay. RC line doesn't take a handler. Okay. I guess I can do, I mean, it's a little bit of superfluous calculation here, but I feel it'll keep us safe, basically. So 127, yeah. So this is a limit, so we're never gonna overshoot, you know. Yeah. So we can get rid of these. This is now the same as here. All of this is the same. The only difference is RC list, and then RC list. I almost want to do a for loop here. Almost, because that'll give us an index, and with the index we can do direct insertion, and I think direct insertion is always going to be faster than a push. So if I do for let I equals 0, I smaller than RC count, I plus plus, we can do I this RC list and RC list I equals RC. Now, is that good enough? Because RC is an array. Do we need to create new arrays on these? Yes, we do. So what's the most efficient way of cloning a JavaScript array? Most efficient way to clone JS array. I mean, it's probably just direct syntactical duplication because it's a small array. like slice is a function call. This doesn't seem very fast. Yeah, I think the fastest will literally be to write it out like this. No, like this. Yes, like this. I mean, I'm breaking my own rules here because on small Sudoku boards, I'm not sure if that ever is going to be relevant. So at the end, we're going to have 6 elements, and the 6 elements should be whatever. All right, so I should just return this at the end, return this here. And this should be the same as these. Yeah, I can get rid of this, get rid of this. RC count is just that. And then the only difference are these 3 lines compared to this algorithm here. Right. So one calls a function and the other one returns an array with the new elements. All right, those are useful. So what else can we do quickly before I need to take a break? We haven't actually dealt with parsing much yet. So let's have a little look at some of the parsing code. So we have something like this. So this would be the hex parser. This would be the RC value. So this is RC plus additional information. RC to num. RC, because that takes RCVs. RC to hex digits. If num to string path start. So this is RC to number. This is okay. That's just the whole thing. Okay. So this is yeah. So we have the whole other thing here, right? The num value here is like the index of the cell from the start to the end. So instead of having an RC, we can also have an index. And then we're going back to all the other stuff that I have in puzzle tools, not puzzle tools. Is it in puzzle tools? It might be in puzzle tools. Yeah, we have all of this stuff, right? So a lot of things, and in fact, we might want to move that into primitives, right? So converting RCs to index values. Now these are all 9x9 based. And I think we can make these more generic. I think these can all be generic. But then we have to be careful. Do we want to create an optimized 9x9 version of them? Because this is stuff that might be used in a solver that we want to be super fast, right? Like here, I'm pre-calculating them, so they become all just static lookup tables, so they become super quick and efficient. But it might be worth doing. It might be worth doing. Not right now, though. I think parsing is a little bit a bigger topic. But we definitely want to do some, like ideally we have a generic parser that can just recognize this, the thing, right? So let's see what something like that might look like, right? So we might have something like this. And we might want to test it in a very simple way. So we want to do something like parse RC R2C7, right? Here, I want to do this. Something like that. And we probably want to have multiple test cases, so we'll do something like this. CC7, and I don't know why that's in there. For each RCSDR. And we'll do this. And we'll just do something like so this will quote things correctly, you know. Something like this. I think that's the problem, right? JSON.stringify RC string. Parse RC. It's not defined because it should be like this. Bada bing, bada boom. All right, and you can disable these for a sec. You can get rid of that. Okay. Okay. So this will be mostly just some very basic regular expression matching, I think, for now. Let's put this down here so we can take a look at this more easily. Let's get rid of that. And we don't need that anymore either. So let's do some basic, like, let's try something like, let's define RC, right? RC should have the letters R and C in it. So const RC. So we'll have an R. We have a bunch of stuff. All sorts of stuff. I think we could allow like a blank column row to define a whole row and column, similar to what spreadsheets do. We could even consider spreadsheet syntax now that I think about it. Spreadsheet. You know, I guess we could. But I think the nice thing about having the letters R and C in there is that they're already like they're recognizable by the community, right? And I think I'm gonna exclude values because I have some data where we have R1, C1, ABC, something like that. And I think a different parser should parse this and then parse the RC afterwards with the RC parser. I think that's how that should work. So if I do RC, RE, RC, does that look like that's a null? Because that's another R. Do we want to allow lowercase? We probably do. We probably do, even if that might cause some issues with hex parsing. Because C is obviously a valid hex number, right? Okay, now it's time for adding additional test cases. So we probably want to do this, and 2.5, 7.5, something like this, and then maybe a large one, 12 and 2, and then something like 12.03, right? Like with leading zeros, and then 12.203.4. Let's have a look what these would look like. So we can pull out these kind of things, right? Let RC this or empty string. At the very least, we get weird values out of there, right? And then we want to parse them as floats for now. And I'm guessing for other formats, we really need format identifiers. And then we just return these like that. Really? I mean, that's all there is to it at the end of the day. Yeah, probably just include that here. Keep it close. Is that enough? I guess so. And do we want to stringify, RC stringify? Or do we want to call it something else? You know, serialize, deserialize, that kind of thing. Parse RC. I mean, we probably want to call this parse, rc.parse. And then we want to call it, you know, stringify RC, rc.stringify, that kind of thing. Parse RC. Oops. Stringify RC. Like that. Like that. And then we're probably gonna do stringify here. Something like that. And for stringify at the moment, it's just gonna be kind of simple. It's gonna be a string, capital R, with RC0 here, C, and RC1 here. For now. Yeah, just start somewhere. And this parsing and stringification should go both ways. Parse is not defined. Parse. Wait a second. Are these the wrong way around? Parse as parse, or parse C as parse. Stringify as that. Yeah. And ideally they handle arrays as well. So if array.is array rcstr, then return rcstr.map. So then the question becomes, do we get an array of RC strings, or do we get some encoding that it can understand, such as no commas, etc., because we have the RCs to recognize it? I don't know. Actually, we can just do this, right? So net RC test data equals, and boom. And then we can do RC parse RC test data. Boom. Okay. And then RC stringify RC test data. Okay, stringify will do the same sort of thing. I can just do this, boom. If array do this, else do this. RC, map, stringify RC, boom. And that's short enough to do it like that. Now the question is it worthwhile doing this check? Because this happens a lot, that check actually recurses inwards, and it could become expensive if we do this type check every time. It might not be worthwhile having this flexibility. Ugh. In other words, you know, this could cost a lot of performance. Array.isArray might be very slow. Ooh. RC stringify. RC. Oh, because it's always an array. Ah, okay, yeah. Let's not do that. Let's not do that. Let's keep it simple. Because, you know, we can just do this. We can just do that. And then we don't need any of, whoops, any of these things. Sorry if that was too small. I should have embiggened that a while ago. It's even small for me. But my new glasses are garbage, so that's probably why that is. And we can close this. Close this. Alright, so let's just clean up the div and just push all that before we call it a day. So maybe something like this, console.log rc. And we want to do some of the other ones. So rc.toRC. And we can just do something like actually we can do that down here. So that parses that, and then we can do rc parse dot map rc dot to RC. I think that should work, right? Boom. Yeah. So that's kind of testing out that bit. And then do we want to just do that separately? Yeah, I think we'll just do that separately, right? So we're gonna do this over here, rc.stringify over here, and then not this at all. And then we can get rid of this, and it's not so bulky. We can actually see what's happening. So parse, blah, blah, blah. Probably want to run this twice. Once with the parse. That's once with the stringify, just like that. Yeah, and anyway, there's lots of other things we can then do. Does that make sense to have that in there? Something like this. Have to be something like that then. And like that. Stringify. Yeah, let's leave it as there. It's just that the console here prints it out differently than it does in the browser, so that always confuses me a little bit. Okay, let's see where that leaves us with this. So we have interactive demos. No, not interactive. Demos. I just want to write that. All right, sort of self documenting. Here we go. All right. I think I'll split these out. And fine. Update, that's fine. Edit primitives and demos. Primitives on demos, yeah. And I'm hearing the dog, so I'm probably gonna take him for a little walk in the sun. You'll love that. All right, and that should already be live on SudokuPad/Sudoku tools. And I feel compelled to say it, but I'm working on the Cracking the Cryptic web app. I'm the author of Sven's SudokuPad. So if you want to support the work, obviously buy SudokuPad, that'll help, but that's only a small part of all the things I do. If you want to help more, there's a Patreon down in the description. You can also find it at patreon.svencodes.com if I've set it up correctly. Let's try it. Patreon.svencodes.com. Yeah, and then there should be a Ko-fi, kofi.svencodes.com. No. All right, I still have to. That's on my to-do list. I gotta set that up. All right, but yeah, that's the easiest way to help me out. And the goal is that I want to use this also to kind of guide my development. So if you're a streamer and you have a special feature request or a setter and you're annoyed that there's a simple thing I haven't done, hey, send me a note, join Patreon, and probably what I'll start doing is maybe I'll do a weekly or bi-weekly stream where I get one of the patrons on the stream, and I'll just for 2 hours do whatever they want me to do, and that'll be fun, I hope. All right, that's it for today. Take care, have a good day, and I'll see you in the next stream.